Hello everyone and welcome to another scientific video, the 12th scientific video of the process of fractions. And today in this video, we are going to discuss how to calculate the mass of the sun in a very easy method. How to calculate the mass of the sun using the law of gravity. That's what we are going to do today. That's what we are going to do today. And first of all, I'm making the same request from all of you. If you have not subscribed to my channel so far, please do it, because this particular channel is little by little providing you the knowledge that you have been waiting for, and little by little this particular channel is going to be one of the largest scientific blogging channels in the world. And let's move on to today's video. Okay, how to calculate the mass of the sun using the law of gravity. Here I have drawn the sun. I have mentioned it as mass m1. M1 is the mass of the sun, and here is the sun. We have the earth here, and the mass of the earth is mentioned as m2, and the distance from the sun to earth is mentioned as r here. And also here's something called omega. Omega means what? Omega means the angular speed of earth at which the earth rotates around the sun. Means in 1 second, how many radians will the earth be rotated around the sun? That's what called the angular speed. Okay, first of all, we are going to use two principles here in this calculation. First one is the law of gravity and the gravitational force, the gravitational attraction between the earth and the sun, between the sun and the earth. Second one is the rotational motion of the earth around the sun, the rotational motion around the sun of earth. So these two concepts are the concepts that we are going to use today to do this particular calculation. Okay, first of all, we are going to take the first equation using the law of gravity. Fg is the gravitational attraction, the gravitational force is equal to G m1 m2 divided by r square. Fg is the force of gravity, G is the gravitational constant, m1 is the mass of the sun, m2 is the mass of the earth, and r square, r is the distance from the sun to earth square. Fc is the force centrifugal, or the centrifugal force. Centrifugal force is the force which is needed for the earth to rotate around the sun in a circular motion. So Fc is equal to m2, the mass of the earth, omega square, the angular speed of the earth, and r, distance from sun to earth. Now, if the earth wants to rotate around the earth, if the earth wants to rotate around the sun continuously, this required force of centrifugal force must be provided by the gravitational attraction, Fg. So Fg has to provide the Fc. It means Fg has to be equal with Fc. So Fg equals Fc. G m1 m2 divided by r square is equal to m2 omega square r. Now what will happen? The mass of the earth will be cancelled out. And finally, what we want to calculate is m1, the mass of the sun, so that we can isolate mass of the sun in one place, and then we can take all the other things to the other side, so that it is called making subject m1. So after making subject m1 is equal to omega square r cube and divided by g, the gravitational force. So m1 is the mass of the sun, omega is the angular speed of the earth, r is the distance from the earth to sun, from the sun to earth, and g is the gravitational constant. Now we have a challenge. Do we know the angular speed of earth? Do we know that? Yes, of course we know. Because why? The earth in every year completing one full revolution around the sun. It means the earth in every year is rotating 2 pi radians around the sun. Now we have to check how many seconds are there per 1 year. This many seconds are there per 1 year. 365.25 days multiplied by 25 hours multiplied by 60 minutes multiplied by 60 seconds. That many seconds are there. So 2 pi radians divided by 365.25 multiplied by 24 multiplied by 60 multiplied by 60 is the angular speed of the earth around the sun. Means angle of the speed around the sun, omega, is equal to 1.99 multiplied by 10 to the power minus 7 radians per second. That is the angular speed of the earth around the sun. Now we can substitute this value in here. and the distance to from the Earth to Sun. As you remember, in our last video, we calculated very easily the distance from the Earth to Sun, and we can use that value in here. And G, we know the gravitational constant 6.67 multiplied by 10 to the power minus 11. Okay, now m1 is equal to omega 1.99 multiplied by 10 to the power minus 7 square of it, and the distance from the Earth to Sun 1.5198 multiplied by 10 to the power 11 meters cube of it, and divide by 6.67 multiplied by 10 to the power minus 11. And finally, after calculating entire slot, you will get the answer as 1.9814 multiplied by 10 to the power 30 kilograms as the mass of the sun. Now you know how to calculate the mass of the sun very easily. You can see this calculation is very simple and very easy. Even the physics students don't know how to calculate the mass of the sun. Now you all know how to calculate the mass of the sun. And thank you for watching today's video. If you like the video, please put a like. If you like the channel, please put a subscription. And see you soon in another video of calculating how to calculate the radius of the sun, and also how to calculate the luminosity of the energy release of the sun. See you soon with those videos. And until then, goodbye and thank you very much. Thank you.